ขอนะครับ
เดี๋ยวแป๊บนึงนะคะเห็นสไลด์แล้วใช่ไหมคะเห็นไหมคะอุ้ยทุกคนเงียบหมดเลย
เห็นครับเห็นครับเรียบร้อยแล้วครับ
แทนใช้อะไรทำสไลด์อะครับ PowerPoint หรือ Canva ครับ
เห็นชัดเจน
PowerPoint ค่ะ
ทุกทีที่ทำ Power ทุกทีก็ส่งผมด้วย PowerPoint นี่หรอ
ใช่ค่ะ
เก่งว่ะสวยดี
แน่นอนตามหน้าตาค่ะ
เมื่อวานจะตอบว่าใช้ที่อัดท
ำเดี๋ยวนี้มันทำสไลด์สวยทำสไลด์สวยแล้วทำเร็วเหลือเชื่อว่ะโอเคขอบคุณครับลุยครับ
Okay, good morning, everybody. Today I will to talk about list-based and hydrodynamic pluvial flood forecast in real time. This research is published on Water Journal of MDPI on March 2019 by Julian Hoffman from the RWTH Aachen University in Germany. Overview this research. They want to present a new framework for the forecasting and warning pluvial flood in the real time. So the framework has a short computational time, fast response and warning, and acceptable accuracy. So let's go introduce pluvial floods. Pluvial floods are caused by high intensity rainfall events or exchange rainfall. It that the urban is inefficient of absorbing rainwater and the capacity of the drainage system is existed. And pluvial floods can occur anytime and anyway, and are increasing problem for cities around the world that makes serious social and economic impact. The cause of pluvial floods by the fast extending urban department and
What is the Thai word?
Thai word pluvial flood is น้ำท่วมขังค่ะ
Thai word for that
น้ำท่วมขัง
ไม่ใช่น้ำป่าคือน้ำรอการระบายของเราเนี่ยหรอ
น้ำรอการระบายค่ะ
โอเคค่ะ thank you
โอเคค่ะthe first is the fast expanding urban development and climate change. The climate change indicates a weather-related increase of the extreme rainfall events in the frequency and intensity. There are the factors leading to increased risk of pluvial flood events. The pluvial flood events has a compact flow pattern and high dynamic nature. To address these risks, the flood forecasting and early warning system or EWS are essential tools to reduce the impact of pluvial flood events. The flood forecast and early warning system have presented a new method that is numerical weather prediction or NWP and radar-based nowcast. There are a step change in rainfall forecasting by providing more accurate and high-resolution data. Moreover, the hydrodynamics models, there are detailed inundation process, representation and pluvial flood risk analysis in urban area. The hydrodynamics models are approach used for the urban flood simulation. The suitable model for the flood are the flood model. The flood model is the integrate between one dimension and two dimensions. The results are used to develop risk analysis, warning, FAT map and the support decision making in FAT management and mitigation. So, Puriel FAT early warning system has the multiple approach of them that can be classified by level of the complexity into the three systems. The first is empirical based length for scenario system. Fast forecast system will not hydraulic model and warning threshold are defined based on historical fact event or knowledge of the local area. And the second is the pre-simulated scenario-based system. The system will scenario and results built from the previous hydraulic simulation and associated impact estimate. There are complexity and quality will depend on the type of hydraulic model and rainfall inputs. It's so expensive and don't require the technician or the highly skilled staff. And the last simulation is the real-time hydrodynamic simulation-based systems. The system with real-time hydraulic model and impact estimation. And the simulations must comply with real-time forecast standards and the short computational time and fast display for result and acceptable accuracy. And the system is so expensive and require technician. So in this paper, focus all based on the real-time hydrodynamic simulation based system at the urban scale because it can directly model inundation and impact connected with the high spatially variability of rainfall forecast. But in the research have the problem is the first, the fast event is very localized and unique. The second, the short lead time of the rain forecast, and is the model used high resolution inundation modeling of the large and complexity scale induced long computational time and must be required spatial infrastructure and high performance computing. So this research objective to present a multi-model concept and a new operation tool for the development of a risk-based early warning system that meets end-user requirements, providing targeted Fourier fast forecasting in real time, and its computational time must be as short as possible, but sufficient spatial and temporal fast accuracy is necessary to derive effective measure for damage reduction. So research approach the multi-model system and the operational implement of the early warning system. The system consists of two parts. The first is offline. Offline is pre-processing, and second part is online. Online is the real-time operation. This is the framework of the system, consists of the two parts. In a zoom in the offline
Pause a little bit
part.
here, please. น้องแววหยุดแป๊บนึงครับ
ค่ะ
well done very good the flow of the reformability is very clear, very good way to present it. I would like everyone to see that it's a good style of the presentation. Okay, the introduction is nice, and then they're trying to give more example, give more details about the problems, and at the end they're gonna give us the research approach, and then they provide the details with they separate in two parts, and then they're gonna give more details about what are that two parts in the detail. Anupam, you should follow this kind of the idea when you present the research proposal. Okay, so
Yes, sir.
And that is very nice one. So at this time they're going to when to present us the research approach in the detail, and it's gonna be very complex after this. Before we go into that direction or that explanation from Van, I would like to ask everyone if there is any problems to ask Van at this time first about the problems, about everything. If it is everything clear, or you want to ask something in Thai or in English, is fine. มีใครอยากถามอะไรก่อนไหมครับว่ามันโอเคไหมก่อนจะได้เบรกน้องแวนนิดนึงเสียงน้องแวนสูงมาก
Oh no sorry ค่ะ วันนี้อยู่ห้องมันใหญ่หนูก็เลยแอคชั่นได้เต็มที่ค่ะ
โอเคทุกทีคุยกันนี่อยู่ต้องงิงคุยใช่ไหมโอเคครับ
ใช่ค่ะเดี๋ยวแม่ด่า
ชอบโอเคดีแล้วแล้วก็ภาษาอังกฤษก็ not bad นะครับมาเป็นคำแต่ว่าก็ไม่ผิดอะไรแล้วก็แวนลองกลับไปดูสไลด์2-3 หน้าผมอยากให้ดูสไตล์เนาะนะครับไปอีกตรงที่มันมีคำอย่างเช่นตอน good point bad point ตอนที่บัตอะไรเงี้ยครับถอยไปอีกครับ
หมดแล้วค่ะ
ถอยไปอีกไปอีกแล้วยังผมยังเห็นถอยตรงนี้อันนี้เนี่ยอย่างเงี้ย research problem มันเป็นยังไงเขาต้องการอะไรแต่มันทำไม่ได้เพราะอะไรอะไรเงี้ยครับไอ้ตรงเมื่อกี้ so and but เมื่อกี้ครับก็ดูน่าสนใจดีแต่ละเรื่องก็แบ่งกลุ่มมาค่อนข้างดีนะครับstructure ของการ presentation นะครับโอเค any problems ครับอาจารย์เอกถามอะไรนะขอโทษครับ
เมื่อกี้ตรงมันจะมี process ตอน offline กับ online อะครับตรง offline มันทำอะไรนะครับ
offline มันจะ pre-process พวก data ก่อนมันจะสร้างโมเดลค่ะตัวนี้มันจะทำเป็น simulation นะคะแล้วมันประมาณว่าที่จะทำ offline เพราะว่าออนไลน์มันต้องการความรวดเร็วดังนั้นมันจะลดอาจารย์ฟังต่อใช่ไหม
เสียงมันหายไป
ลดเวลา
ครับ
ลดเวลาค่ะดังนั้นมันก็เลยมีทั้งฝั่งออฟไลน์และออนไลน์ค่ะ
ครับทีนี้ข้อมูลที่จะเอามา pre-process ตรงออฟไลน์เนี่ยมันต้องใช้ข้อมูลในอดีตใช่ปะครับ
ใช่ส่วนใหญ่จะเป็นข้อมูลในอดีตค่ะไม่เชิงว่าเป็นถือว่าเป็นข้อมูลในอดีตก็ได้ค่ะแต่เป็นเชิงพื้นที่อะไรพวกนี้ค่ะอาจารย์ต้องติดตามตอนต่อไปค่ะ
อาจารย์ไม่แค่อยู่หรอกว่าในทาง practical เนี่ยคือถ้าเกิดเรามีข้อมูลในอดีตเราต้องแบบเอาย้อนทั้งหมดหรือว่าย้อนแค่บางส่วนหรืออะไรอย่างเงี้ยครับแล้วเมื่อไหร่จะ process มัน offline คือเมื่อเกิดน้ำท่วมค่อย process ทีหรือว่าครบ1 วัน process ที1 วัน process ทีอะไรเพราะมันเหมือนว่าข้อมูล offline จะต้องถูกนำมาใช้ทันทีเมื่ออะไรอย่างเงี้ยครับเลยรู้ประเด็นตรงนี้ครับ
ในเปเปอร์นี้เขาไม่ได้บอกว่าฝั่งออฟไลน์จะอัปเดตเมื่อไหร่แต่ถ้าเป็นฝั่งออนไลน์คือข้อมูลไหลเข้ามาทุกๆ5 นาทีแล้วมันจะมีตัวสวิตช์ตัวหนึ่งที่เป็นเทรดโชว์ว่าจะวอร์นิ่งเมื่อไหร่เงี้ยค่ะถ้าข้อมูลน้ำฝนเข้ามาถึงระดับนี้เงี้ยค่ะ
ครับคือประเด็นของผมนิดหนึ่งคืออันนี้ไม่ใช่ถามแบรนด์แต่ว่าประเด็นที่สงสัยนิดหนึ่งคือข้อมูลที่เรียลไทม์ณตอนนี้เนี่ยจากนั้นมันจะกลายเป็นอดีตใช่ไหมครับคือว่าข้อมูลเนี่ยตัวนี้มันเรียลไทม์ใช่ปะพอพวกนี้ไปปุ๊บมันคือข้อมูลอดีตใช่ปะดังนั้นข้อมูลอดีตเนี่ยมันจะต้องเอาไปรวมกับข้อมูลออฟไลน์เพราะฉะนั้นเนี่ยประเด็นของเราคือเราจะต้อง process ออฟไลน์ถี่แค่ไหนอะไรอย่างเงี้ยครับเลยสงสัยเฉย
ๆในที่นี้เหมือนเขาจะแค่อัปเดตเทรดโชว์บางอย่างที่มีในออนไลน์อะค่ะถ้าสมมุติว่ามันมีตัวทริกเกอร์สักอันหนึ่งที่มันทำให้ต้องวอร์นิ่งเขาก็จะเก็บบล็อกไว้ไปอยู่ในออฟไลน์ค่ะ
ครับมันจะแบบอย่างช่วงที่แบบเริ่มเข้าฤดูฝนใหม่ๆเงี้ยถ้าเกิดเราเอาข้อมูลสมมติว่าอดีตมาใช่ไหมครับมันจะเป็นอดีตที่ฝนไม่ค่อยตกแต่พอแบบ วันเนี้ยเป็นสมมติว่าเป็นวันที่หน้าฝนที่ฝนตกจริงๆวันนี้ไปปุ๊บข้อมูลฝนจะตกเยอะพอพรุ่งนี้ไปข้อมูลของอดีตของวันนี้ของเมื่อวานเนี่ยมันจะเป็นข้อมูลที่ไม่เหมือนปกติแล้วมันจะต้องเอาไปรวมกับออฟไลน์แล้วจะรวมกันยังไงเมื่อไหร่อะไรเงี้ยครับน่าสนใจดีครับ
ใช่ค่ะแต่เท่าที่หนูอันนี้นะคะเหมือนฝั่งทางงานเนี้ยเขาจะใช้ข้อมูลสเกลเป็นรายปี
อ๋อเป็นช่วงสัปดาห์เดือนนี้ของปีอะไรอย่างนี้เลยใช่ไหมครับ
มาเป็นข้อมูลหนึ่งข้อมูลแทนข้อมูลทั้งปีค่ะอาจารย์
อ๋อครับ
เหมือนพวกความสูงอะไรพวกนี้เขาก็สำรวจ1 ปีแล้วก็ใช้ข้อมูล
มันเป็น
reference
ข้อมูล
ทั้ง
ที่ไม่ได้
ปี
เปลี่ยนเร็วอะไรอยู่แล้วอย่างนี้ใช่ปะครับ
ใช่ค่ะ
อ๋อครับ
อย่างน้ำฝนก็เป็นน้ำฝนสะสม100 ปีน้ำฝน100 ปีอันนี้หนูก็ไม่รู้ความหมายนะคะ
ครับอ๋อโอเคครับขอบคุณครับ
ให้หนูต่อหรืออนุพัมต่อคะต่อดี
แวนอีกนิดนึงก็ได้ครับเราโฟล์ตัวนี้ก็ได้ไหนขอดูอีกหน้านึงถัดจากนี้จะเป็นอะไรนะครับ
อันนี้หนูจะลงดีเทลเป็นออฟไลน์แล้วก็แต่ละกระบวนการเลยค่ะว่าแต่ละกระบวนการเขาทำยังไงหนูให้ดูสไลด์คร่าวๆแล้วเขาก็มีการทำคัตเตอร์ลิงด้วยแล้วก็เขาก็จะทำการจำแนกพวกนี้ออกมาค่ะอันนี้เป็นฝั่งออฟไลน์แล้วก็นี่เป็นฝั่งออนไลน์นะคะอันนี้ออนไลน์เขาก็จะมีโปรเซสคือเอาข้อมูลเทรดโชว์ที่มาจากออฟไลน์แล้วก็รับข้อมูลอินพุตที่เป็นเรียลไทม์มาเรื่อยๆแล้วกระบวนการเขาก็คือเมื่อเทรดโชว์ค่าน้ำฝนสักอย่างเกินค่าเทรดโชว์ที่เขาตั้งไว้ก็จะมาวอร์นิ่งโดยการไปดูสับแคชเมนต์ว่ามันเกิดตรงไหนเนี่ยค่ะแล้วเขาก็จะวอร์นิ่งตรงสับแคชเมนต์อันนี้ก็จะเป็นอีกเยอะอยู่ค่ะ เนี่ยค่ะแต่มันเจ๋งตรงที่ว่ามันพีดิกค่ะพีดิก1 ชั่วโมง2 ชั่วโมงล่วงหน้าแล้วก็เกิดน้ำท่วมจริงแล้วเขาก็เทียบกับสถานการณ์จริงที่เกิดขึ้นว่าระดับที่เขาพีดิกเป็นเท่าไหร่เนี่ยค่ะประมาณนี้ให้หนูต่อเลยไหมคะ
โอ้โหดูดีผมยกเลิกประชุมยุทธศาสตร์ITSCแล้วกันผมนั่งฟังอยู่นี่ดีกว่า
เอ้ยอาจารย์คะแต่ที่จริงมันไม่มีอะไรเลยนะคะ
ตอนนี้แบบเริ่มคิดวิตาแล้วหนูเตรียมมาแค่ครึ่งชั่วโมงครับ
อุ๊ยอาจารย์ต้องไปดูเปเปอร์หนูช็อกอยู่ว่าหนูเลือกมาได้ไงเนี่ย
มันยาวใช่ไหมแต่ก็ยาวแล้วเขาก็เล่าละเอียดมันเทรดออฟกันครับถ้าเป็นพวกเปเปอร์สั้นๆมันก็งงๆแต่พอยาวเขาก็จะเล่ามาเยอะเนาะพี่ท้อยังอยู่ไหม
แต่เปเปอร์สั้นๆชอบแบบละไว้ฐานเข้าใจแต่ไม่เข้าคนอ่านไม่เข้าใจตาม
โอเคไหมครับเปเปอร์ครับพี่ท้อ
โอเคค่ะกำลังสนใจอยู่ว่าแบบเขาจะทำนายแบบไหนอะไรอย่างเงี้ย
คิดว่าตัวที่กำลังจะส่งน่าจะลอกเรียนคล้ายๆอันนี้แหละมีออฟไลน์ก็คือไปทำเรื่องของตะกอนแล้วก็ไปทำเรื่องของเรียลไทม์ก็แบ่งมาเป็น2 โปรเซสคล้ายๆกันอะไรอย่างเงี้ยครับ
อ๋อค่ะเดี๋ยวลองดูค่ะเพราะตัวนี้น้องแวนบอกว่ามันเป็นรายปีด้วยก็เลยสนใจว่าเขาทำนายยังไงเพราะว่าเขาทำนายได้ค่อนข้างแม่นที่น้องแวนบอก
แต่ตอนที่เขาทำนายเป็นรายทุกๆเหมือนเขาเจอค่าหนึ่งปุ๊บเขาก็จะมาเป็นเรียลไทม์เนี่ยค่ะแต่เขารับข้อมูลเข้ามาเป็นเรียลไทม์หมดเลยแค่น้ำฝนนะพี่ท้อเขาใช่เขาสนใจแค่น้ำฝน
ดีครับเนาะดีเนาะพี่ท้อเนาะขอสปอยผมนิดนึงขอดูตอนจบหน่อยขอดูตอนจบ
ด้วย
ได้ค่ะตอนจบที่หนูว่ามันเป็น point ที่จริงตัวนี้สำคัญไม่รู้หนูคิดว่าตัวคำว่า hotspot ของเขา hotspot คือพื้นที่เสี่ยงต่อการเกิดน้ำท่วมเขาสามารถเอาข้อมูลในอดีตคือประเทศเยอรมนีมันเขาบอกว่าเขาจะเก็บจากการemergency cell ก็ emergency call ก็คือเขาจะโทรมาหาพวกดับภัยว่าเกิดพื้นที่ที่ไหนแล้วเขาก็จะเรคคอร์ดไว้อย่างเงี้ยค่ะแล้วเขาก็จะมาทำการจัดกลุ่มว่าบริเวณไหนที่เกิดน้ำท่วมมากที่สุดเนี่ยค่ะแล้วเขาก็จะมาทำเป็นพวกจุดสีแดงๆพวกนี้ก็จะเป็นจุดที่เป็นคอว่าเกิดน้ำท่วมใช่ค่ะแล้วเขาก็จะทำหาแคชเมนต์แล้วก็ทำเป็นสับแคชเมนต์เพราะว่าเขาบอกว่าทำเป็นสับน่าจะเร็วกว่าเงี้ยค่ะแล้วเขาก็จะมีการกำหนดเทรดโชว์ของเขาค่าน้ำฝนอะไรพวกนี้ค่ะแล้วก็อันนี้เขาก็จะมาเปรียบเทียบกับความเร็วว่าเห็นไหมว่าถ้าเขาทำละเอียดแบบ1 ตารางเมตรกับ5 ตารางเมตร8 ตารางเมตรมันใช้เวลาต่างกันนะอะไรอย่างเงี้ยค่ะแล้วเขาก็จะเลือกพวก5 กับ 8ไปเป็นออนไลน์แทนแล้วก็ถ้าทำเป็น1 ตารางเมตรก็จะเป็นแบบออฟไลน์เพราะต้องการความละเอียดค่ะ และอันนี้ก็จะเป็น PD กันฝนล่วงหน้าแต่หนูว่ามันเจ๋งตรงนี้ค่ะอาจารย์ มันสามารถ PD ได้ว่าตรงไหนที่จะเกิดน้ำท่วมและน้ำท่วมนั้นสูงประมาณเท่าไหร่โดยเขาใช้ภาพถ่ายจริงและเขาตรงกรอบสี่เหลี่ยมนี่คือเขาประมาณว่าข้อเท้าคนก็น่าจะสูงไม่เกินกี่เซนแล้วเขาก็ดูจากโมเดลที่เขา predict ออกมาว่าได้เท่าไหร่อะค่ะ
มีเรื่อง
ประมาณนี้ค่ะงานนี้
image
ใช่
processing นิดๆว่า
ไม่ถึงว่าเป็น image processing เพราะว่าไอ้รูปนี่คือรูปจริงแล้วเขาไม่ได้ detect นะคะเขาประเมินจากสายตาเขาค่ะสายตาของ expert ไม่ได้ใช้ image เลยค่ะ
ใช้คนอย่างพี่ทอมานั่งบอกระดับน้ำเอง
ใช่เพราะว่าเนี่ยค่ะเขา estimate เอาเป็นช่วงแบบ18 ถึง 22 เซนอะไรพวกเนี้ยค่ะ
ความคนแบบพี่ทอด้วยอะไร
ก็แบบมองออกไงว่าน้ำไหลไม่ไหลด้วยความเร็วเท่าไหร่สูงเท่าไหร่อะไรอย่างเงี้ยโอเค
ค่ะเพราะว่ามันเป็นน้ำท่วมขังด้วยมั้งคะมันก็เลยง่ายกว่าแฟลดที่มาแบบไม่รู้ทิศทางเพราะว่าอันนี้ส่วนใหญ่ก็จะท่วมพวกถนนเงี้ยค่ะทางเท้า
โอเคสวยงามครับดูต้องแดดตอนต้นกันไปไล่ต่อตั้งแต่ตรงเมื่อกี้เลยครับ
ได้ค่ะแล้วอาจารย์ให้หนูสปอยก่อนทำไมไม่รู้ล่ะค่ะหนูรู้ว่าอาจารย์
ดูแล้วมันน่าดูแล้วไงอาจารย์ไม่ไปประชุมแล้วอาจารย์โดดละช่างมันเดี๋ยวเขาโทรตามค่อยไป
อุ้ยอาจารย์ขนาดนั้นเลยเหรอคะค่ะสวิสภาษาแป๊บค่ะ
หายใจเข้าลึกๆก่อนนะโอเค go back to English version thank you
is the part of the offline processing. The offline processing consists of the four major. The first is the fast list analysis, and the second determination of hotspots, and the delineation of USCM model. USCM model is urban subcatchment model. And the threshold is the first is the rainfall threshold or R threshold based on a certain inundation hazard value or F threshold. The last method is the real-time optimization by monitoring the slow reduction through the adjustment of hydrodynamics model parameter. In the detail, the first process, fast list analysis. The fast list analysis combine hydrodynamics inundation simulation and GIS-based damage potential analysis. You can see the picture. This is the component analysis and assessment of the fast list analysis. The first is sorry. The geo database. The geo database for the basic models is the collection is the, for example, the topography, depth, and land use. And the input is the next is the hydronumerical models for the simulation of runoff and flow process. The output of the hydronumerical is the hazard analysis. The next is the GIS model for the analysis and classification of the urban infrastructure. The output is damage potential analysis. The damage potential analysis, you can see the table. The table, for example, is the land use. For example, park or green level is have damage potential is low or is the class 1, and the hospital power supply and subway access is the very high damage or the class 4. So the combined mapping of the fast hazards and damage potential intersect with this map. The picture shows the combined mapping of the fast hazards and damage. And the least metric. The least metric is the conditions between water depth and damage potentials. Finally, the output of the process is a fast list analysis. It can represent which area there is a high risk or the low risk for the flooding. And the next is the determination of hotspot. In this paper, it means vulnerable area or historical infrastructure or water sensitive spot. It makes for the fast list analysis. So this research is use DB scan for the make the hotspot. DB scans are used to locate area with the highest density of the flood-affected infrastructure. DB scans or density-based spatial clustering of the applications with noise. Clustering is done according to the density of the data, so it is independent of shape and size. So DB scan is also successful in arbitrary shape large database and is not affected by the noise data. This shows the basic concept of DB scan. The DB scan requires the two major parameters are the first mean PTS or mean point is the minimum number of points in the neighborhood, and ESP or epsilon is the last gradient of neighborhood at around the point. You can see the red circle. The red circle is have the 1, 2, 3, 4. This means point equals 6 and epsilon is 4. So the red circle is X. X is core point. The core point is a data point that contains greater than or equal to mean point, which in gradient epsilon is the neighborhood is 6 equal the mean point. And the next is the Y. The green point is Y. Y is called border. Border is the number of neighborhoods is less than minimum points, but it belong to the epsilon neighborhood of same core points, and the Z point is the same Y point is the Z is the neighborhood is 1 and 2. So Z is the border and Z is in the Y. The Y is in the X. So the X, Y, Z is the one cluster. And the next is the noise. N is the noise. The noise is the noise. ค่ะ
พี่ขออินไทย
อินไทยได้ค่ะ เอาตั้งแต่ตัว DB สแกนใช่ไหมคะ DB สแกนมันจะมีพารามิเตอร์ที่มันต้องการ2ตัวก็คือตัวแรกก็คือตัวเพื่อนบ้านที่น้อยที่สุดที่มันยอมรับได้กับอีกอันหนึ่งก็คือรัศมีดังนั้นตอนนี้แวนกำลังยกตัวอย่างว่าอย่างเช่นสมมุติจุด x นะคะมันมีทั้งหมด6ตัวมันมีค่าเท่ากับตัวมินิมัมพอยต์พอดีดังนั้นมันจะเรียกตัว x เนี่ยค่ะว่าเป็น core point แล้วต่อมาเป็นตัว y เราลองมาดูวงกลมแล้วก็ทำรัศมีรอบตัว y ตัว y มีสมาชิกทั้งหมดรวมตัวมันเองมีทั้งหมด1 2 3 4มี5ตัวซึ่งมันน้อยกว่า6มันจะเรียกตัวเองว่าเป็นบอนเดอร์ค่ะแล้วก็ตัว Z ก็เหมือนกันตัว Z ก็คือเป็นวงกลมสีเหลืองวงกลมสีเหลืองจะมีแค่2ตัวแล้วมันก็ถือว่าเป็นบอนเดอร์เพราะว่าตัว Z เนี่ยค่ะมันเป็นสมาชิกที่อยู่ในตัว Y แล้วตัว Y เป็นสมาชิกที่อยู่ในตัว X ดังนั้น ทั้งหมดเนี่ยค่ะมันก็เลยถือว่ามันอยู่ในกลุ่มเดียวกันค่ะและต่อมาก็คือตัว noise นี่ก็จะคือเป็น outlier เลยก็คือมันมีจำนวนไม่ถึง minimum point และรัศมีมันก็ไม่ได้ซ้อนทับกับตัวอื่นๆด้วยยกตัวอย่างเช่นรูปรอยยิ้มนะคะจะเห็นว่ามันสามารถทำการจัดกลุ่มได้โดยไม่ได้สนใจรูปร่างลักษณะหรือขนาดไซส์เพราะว่าจะสังเกตว่าตอนนี้มันสามารถจัดกลุ่มได้ออกมาทั้งหมดนี้ทั้งหมด1 2 3 4 กลุ่มเนี่ยค่ะเขาก็เลยบอกว่าตัว DB scan นะคะเป็น clustering ตัวหนึ่งที่สามารถจำแนกได้โดยไม่สนใจขนาดแล้วก็รูปร่างลักษณะหน้าตาค่ะพอเข้าใจไหมกันไหมคะ
โดยมันจะดูจากระยะห่างเหมือนถ้าเรามองด้วยตาก็คือเอาที่มันเป็นกลุ่มจริงๆใช่ป่ะ
ใช่ค่ะ
ตัวรัศมีที่ใช้เนี่ยมันจะใช้เท่ากันทุกตลอดเลยใช่ป่ะมันเป็นพารามิเตอร์ที่เป็นฟิกเหรอ
เป็นฟิกค่ะเป็นฟิกเท่ากันตลอดแล้วก็มันก็จะหมุนไปเรื่อยๆตามตำแหน่ง point แต่ละ point ว่าตัว point ตัวนี้ยังอยู่ในรัศมีที่โดเนทกันไหมอะไรอย่างเงี้ยค่ะมันก็เลยเหมาะที่สำหรับงานนี้นะคะที่จะเอามาทำการจัดกลุ่มคนที่โทรแจ้งว่าน้ำท่วมตรงไหนบ้างเนี่ยค่ะเขาก็จะได้รู้บริเวณน้ำท่วมแล้วก็มัดรวมกันเป็นก้อนเดียวค่ะโอเคค่ะต่อไปนะคะต่อไป the next slide is the delineation USC model. USC model is a urban subcatchment model. Is the length of effective area forming the discharge relevant urban use surface for inundation at individual hotspot. And the component of the USC model, the dot line represents subcatchment border and the pink area is subcatchment. The catchment is mean พื้นที่รับน้ำนะคะ The next is the lead point. Lead point is the drainage point defined as junction of critical overland flow paths induced by rainfall events. And the house icon is represent the infrastructure in urban. And the blue line is the main flow path. And the red circle, the big circle, is the hotspot area. The next is the R threshold and F threshold. F threshold is are defined for inundation that reach a critical level and are connected to flood related value. That value are the water depth, flow velocity, or the product of both parameters. And the R threshold is the initial warning and trigger subsequent real-time simulations. Initial warning and based on automated process of hydrodynamic simulation. And the hydrodynamics real-time optimization to make the operation implementation of real-time simulations available for mid-rank computer that require reduce the computational time of physically based fast simulation. So the objective of method to achieve optimized solutions between computing speed, level of detail, and results usability. and the performance of this model in terms of accuracy and processing speed or computational time. The accuracy part use RMSE, root mean square error, and R square. The root mean square error is n represent the number of observations or element, and SI is the water depth or velocity of the simulations. OI represents the water depth or velocity of the optimized simulation, and the path of processing speed. The processing speed is the reduction to computational time as speed up ratio is calculated by a time of GPU per time of GPU optimization. Is the time of GPU is the runtime of the high performance model, the high performance model or HP model, and the GPU up is the runtime of the real-time optimized model or RT model. And the path of online is a real-time operation. The real-time operation in this research, the proposed PFA operator is the consist of the T part. The first is nowcasting, the second is a real-time processing, and the last is warning. In the zoom in the first, in the step of the process. The first is nowcasting. The nowcasting is a receive for require the length for forecast data is the two source. The first is DWD. DWD is German meteorological service, and the second source is the Hydromaster. The Hydromaster is the web service, and receive the data and accumulate over the target interval is the 30 minutes or the 60 minutes or the 120 minutes is the represent the TFX. If the threshold monitor is the push each threshold from the database is compared between the TFX and TRX. TRX is the from threshold database. If the threshold less greater than TR is 4 or no is no warning, and if the true is yes, is the warning kind. The warning kind is the is the path to the model broker. The model broker is correct. The OASYS model is the subcatchment. And warning, the warning is the two types. The first, the simulations result to a dynamic flash forecast containing warning about exceeded maximum inundation depth and velocity, including flooding time for selected area with the high risk. And the second output is the flash forecast by sending a dynamic inundation map. Example is the SMS or email or in websites. The next is the system implementation and result. The first is the study area. The study area is the Aachen. Aachen is the city in Germany. Is the Aachen have the river named Warm River. The Warm River is the flow to the city in the kernelized form, and the landform average per month is the 75 millimeters per month. And the dataset is used the 29 May 2018, and emergency call is documented by the fire department of ACR. Is the number is the 379 call, and this paper use the parameter is the one's metro resolution, digital elevation model, and land use map, building object, radar based landform measurement, and the observation in the FAT is the photo. And you can see the picture. The picture show the digital elevation model of the study area, and including positions of emergency call. The emergency call represent the red circle. The red circle is the smallest circle, is the count is around 1 or 2, and the big circle is number around 18 to 20. And the software and model data. The software is the hydrodynamics model. Software is Mike 21 version 2019, and detail is the Mike 21 is the physical based simulation of urban inundation process. Advantage: the first can be used for a compact model structure in urban flood simulations, and can represent the dynamic interactions between the storm damage network and urban surface. And the data is the landfall forecast data in the use the short-term radar based forecasting. ยังได้ยินเสียงแวนอยู่เนาะค่ะ and the forecast is detecting speed and direction of storm events and providing quantities precipitation forecast in the source is the two way. In the first is DWD. DWD is the high space spatial is 1 square kilometer, and time resolution allow 5 minutes. And the second is the hydromaster. The hydromaster is the high spatial 1 square kilometer, and temporal resolution if 3 hours. The result in this research. The first is hotspot localization and validation. You can see the picture. The picture is the use DB scan is the minimum 0.5, and epsilon is the 50 meter, and the picture can classify or clustering is the 11 clustering, and these results comparing the number and locations of the hotspot resulted in 9 simulated and 11 event-based hotspot. Its hit rate allow 82%. The next is the determination of USC models and artificial. You can see the picture in the left-hand side. It shows the sub-catchment in this research. In the which is to the brown area. The brown area is the capacity. The capacity is the most severely affected area and has a key coordinate point in the K1, K2, and K3. And the threshold calculate for the hotspot K3 is have the F threshold 1 and F threshold 2 is if threshold is equal 0.2 is the shoot R threshold 1 and if F threshold equal 0.5 it shoot R threshold 2. And the real-time optimization for USC model is the output of the simulated separated by the resolution A, B, C. A is the 1 square meter and B is the 5 square meter and the C X square meter. Performance the processing speed of the resolution is the compare with the 1, 3, 5 and X square meter. Is a number of elements is the 1 square meter is the most and the 5 and 8 is the less than the 1 and the time CPU and GPU you can see in the table. And SS is ratio between a time CPU and time GPU. So is the 5 square meter and X square meter is the less. And the next is the performance test of the PFA operator. The length for measurement and 2-hour forecast of the May events based on assume that the forecast equal the measure length for a month. The R threshold is the R threshold is or R1 is the warning and subsequent dynamic fast forecast follow in 5-minute interval F1, F2, F3, F4 and F5. The lead time of the R1 represents allow the 125 minutes. This the time 12:55 or the fast occur around the 15th o'clock. And the next is the performance test of the PFA operator. And you can the result show the event in the position A, B, C, and D. The x-axis represent the time and y-axis represent the water depth. Is the in the 3 line represent the first is full line represent the high performance HP 1 square meter and the red line represent the RT 5 square meter and the green line represent RT X square meter and the box represent source or in situ. And you can map the graph and this picture A, B, C, and D and the picture show the event occur. So the estimates of depth and simulated depth for selected location in the central area of occur, including total computation time and speed up ratio for the different simulation. Now the simulation is the 3 simulations, is the HP1, RT5 and RTX. Is the estimate from the picture. The event A is the less box, the water depth allow the 18 or 20 centimeters in the model can be predict allow 20 centimeter too, and the situation C, the C is the picture in the estimate for the from the picture allow the 60 or 70 centimeters, and the model HP1 predict allow the 79, RT5 predict 80, and model RTX predict allow the 77 centimeters, and the three simulation predict is summary, and the total time if the simulation one is a loss of time allow the 3 hours, and the simulation is RT5 and RTX allow the 5 minutes and 4 minutes, and SS is speed up ratio compare between RHP and RT5 is the 60%, and the RTX is allowed the 90. So the model RT5 and RTX okay, and it can use in the real-time operation. And the conclusion in this study, they propose a multi-model controller for the development of a list-based end-to-end early warning system, and that to issue impact-based threshold warning and dynamic inundation forecast use standard computer system. And the result of the offline and online simulation, the offline processing is have the result obtained from the hotspot validation indicated sufficient heat rate allow the 83%, and delimitation of the USC model show very resolvable and good results. The path of the online is the final performance test speed up ratio allow the 60.9 and 90.4 by the RT5 and RT8 compared with the HP1, and the depth measurement show the sufficient accuracy with RMSE of the maximums allow the 3 centimeter and the 4 centimeter. The combine and the last in the combination of the threshold-based warning and real-time simulation, the system proved to be efficient and cost-effective by providing warning indicators that can be adapted to arbitrary urban development. Thank you. And you have question? ไม่มีก็เป็นมีคำถามอะไรไหมคะพูดคุยได้ค่ะหนูจบแล้วถ้าไม่มีจะได้ส่งไม้ต่อให้อนุพัมค่ะ
Hello.
The next present. Okay.
Okay.
AO.
Should I start now?
Okay. waiting แป๊บอนุพัมมีคำถามอะไรไหมคะ
ผมไม่มีคำถามครับ
ขอบคุณค่ะถ้าไม่มีเดี๋ยวจะได้ให้อนุพัมพรีเซนต์ต่อค่ะงั้นเป็นอนุพัมเลยนะคะอนุพัม you start
Hello. Hello. Should I start?
Yes.
Yeah, I think so. Go ahead.
Okay. Thank you. This research proposal is on PM 2.5 concentration value estimation of temporal images using image processing and weather data regression analysis. So first you'll understand what particulate matter is. Particulate matter, short PM, stands for the term, also called as particulate pollution, is the term for a mixture of solid particles and liquid droplets found in the air. Some particles such as dust, dirt, soot, or smoke are large or dark enough to be seen with the naked eye. Others are so small that they can be only detected through electronic microscope. PM 2.5 are that small particles which are lesser than 2.5 micrometers in diameter. The health hazards of PM 2.5 are that they can directly go inside the lungs and cause breathing problem, respiratory problems. So the people living in polluted areas tend to suffer from respiratory problems. They get to these particles get to the end of the respiratory tract with the airflow and accumulate within the lungs of the body. We have a need of PM 2.5 level estimator because the AQIs, the air quality index, should be known to everyone who live in a polluted environment. So it is necessary for the public to know the AQI value. But the air quality measuring stations can't be provided throughout the city. So only a few air quality measuring stations are there, and there is a lack of real-time pollutant measurement present to the public. People residing in the areas without any AQMs can rely only on the measurements obtained from the nearest AQMs. So hence we need an alternative PM 2.5 estimator. Due to this reason, and we having affordable smartphones which can take good photos, estimating PM 2.5 directly from photo is a good research topic. In the previous research works, studies can be categorized into two groups. One is image feature based approach, and second is the deep learning based approach. In the feature based approach, we select the features which are to be taken out from the images. But here, the performance of these feature-based approaches can be distorted easily if there is an environmental change in condition. In CNN-based PM 2.5 estimation, we see that the deep learning models improve the estimation accuracy and performance because they don't manually, in this particular approach, we don't manually select the features. The features are directly selected of the images. So hence, it gives us better performance and accuracy. But CNN faces an issue of degradation when we start increasing its layers. And instead of improving the accuracy starts decreasing. This particular decrease in accuracy was resolved by residual network. The residual network doesn't it tries to avoid the degradation problem by using identity mapping. In the identity mapping, the previous feature doesn't get degraded because it is feed forwarded to the other layer. So hence, if we see in the image, the X value is feed forwarded to the next layer, and hence the HX becomes the FX plus the previous X. But these residual networks can be like the base of, and we can base of the model, and we can make new changes and new alterations to the network. The first alteration which was made to the residual network was hello. Okay.
Yep, go ahead.
Okay. Efficient ResNet is a modification done to the ResNet in which compound scaling is done. Basically, what happens here is the image size is taken, the resolution size is taken, and hence by using the formulas for understanding the depth, width, and the image size, we also understand the computational time. The computational time can be calculated via the network depth, the width, and the image size. So if we see here, the channels, the baseline, if that is our algorithm, we can do width scaling in the second one, we can do depth scaling, we can do resolution scaling. The whole combination of all these is compound scaling. So efficient ResNet is a convolutional neural network architecture and scaling method that uniformly scales all the dimensions, depth, width, resolution using compound coefficient. It has demonstrated in previous articles that it gives better performance than the original ResNet models. The second type of ResNet model is assembled ResNet. In assembled ResNet, more alterations are done by using small tweaks like ResNet D, selective kernel, drop block, anti-aliasing filter, and big little network. In the ResNet D structure, the stride size means like there are three things which happens inside the ResNet D. One, we can change the stride size of the first two convolutions in the residual path. Second, the 2x2 average pooling layers with a stride size of can be changed with the side of 2 before convolution in the skip connection path. Third, the big convolutions like 7x7 convolution can be replaced with small 3x3 convolutions in step layers. The second type of tweak which can be done is selective kernel. Here, two convolutions of the same kernel size can be replaced with one convolution with twice as many as channels. Because of this, the inference cost becomes lower, and the process of inference cost is basically inference is basically the process of making a prediction. So by using selective kernels, we can reduce the inference cost. The drop block basically is another tweak, which is a structured form of dropout. What happens in drop block is if we have a certain area of an image of which one feature is taken and the other areas we don't need, we can drop that area completely and just take that one particular feature. Like if you understand in the assembled ResNet, means like in the block of this assembled ResNet, we have taken the blue color and the rest of the color is not needed, means like only one area is taken. So rest of the block of the blue color can be dropped. Then comes anti-aliasing filter. Anti-aliasing filter is used to improve the shift equivariance of the deep network. The equivariance means that how fast the output changes with the input. So by using anti-aliasing filter, the change in output to the input, it increases faster, the speed of the change. Then comes big little network. In big little network, we apply multiple branches which are big and little with different resolutions to aim to reduce the computational cost and increase the accuracy. So overall, assembled network is nothing but a lot of permutations, combinations done to achieve a result. And this particular method has also shown that the efficiency can be improved and the performance can be improved up to the mark of efficient net models also. Now we'll see the relationship between meteorological features and PM 2.5. The atmospheric conditions that create weather, which are air pressure, temperature, and humidity, affect the air quality. First, we'll talk about the wind speed also. If there is a storm, a small storm, it can wash out the pollutants from the atmosphere or transport them to a new area. But if there is a big storm or the wind speed is high, then pollutants from other area can come and get trapped inside the area. So both ways, the wind speed and the direction of the wind speed plays an important role in the actual PM 2.5 value. Second is the air temperature. Now the air temperature affects the movement of the air. That is, it can go up or down. The air near the ground is warmer than the air that is further up the troposphere. During high temperatures, the warmer air, the lighter air rises, and the cooler air, heavier air, than the cooler air and the heavier air in the upper troposphere sink. This is known as convection. Like what happens means, like if there is warm air or if there is smoke, it starts moving up and the pollutants from the ground go higher. But if the air is cooler, then the air from above will come down and the pollutants get trapped inside the area. So in both the ways, air temperature plays an important role to affect the PM 2.5 value or the concentration. Humidity up to a certain extent increases the PM 2.5 levels, and then when the humidity increases up to a certain extent, the PM 2.5 levels, it helps in decreasing the PM 2.5 levels. So humidity has an inverted V shape, or we can say A minus the dash in between relationship with the PM levels. We'll talk about long short-term memory here. We are going to use long short-term memory, LSTM, as regression analysis in this research. So long short-term memory, it consists of forget get, input get, and output gate. It has a hidden gate, cell state, and also the weights and the biases can be tuned whenever we want to. This network also solves the problem of gradient descent, as it has a memory. We are going to use this long short-term LSTM for regression analysis in the research between the image features and the weather features. Now we will talk about high dynamic range. High dynamic range is a technology that improves the range of color and contrast in a digital image. When it's like you might have seen in cameras, if we try to focus it better and if we change the settings like the ISO settings, increase the exposure or increase the contrast or increase the ISO settings, then the clarity of an image, it changes depending on the view. So when you use high HDR images, we can see that the contrast is really good of the image. Normally HDR images are taken by taking n number of a few images, like a burst shot of images, using a range of colors and contrast, and the best one is chosen. But nowadays in smartphones, what happens is you already have an HDR option in your camera. So the latest phones, I think from 2019, they have this option in their camera of directly taking an HDR photo. So after taking an HDR photo, the clarity and the contrast and the we can actually understand the objects quite clearly. In the left photo is the HDR photo and the right photo is the non-HDR photo. If you see in the left photo, the clouds can be clearly seen, whereas in the non-HDR photo, because of exposure difference, the clouds are not seen. So because of such change in images, and by using HDR, the PM means like as we are taking feature extraction of PM 2.5 value from images itself, we would be able to extract features in a better way. Now, Vision Air is a group which has developed an Android app which directly takes images and gives the estimation in the app. So Vision Air is developed to tackle the problem of data generation using federated learning also. Hence, they are continuously getting a large number of data sets. They have developed an Android application to give image-based estimation of the air quality index. So at the same time, means they are on GitHub also. So they have shared a certain part of that data set online. This data set consists of 906 HDR images and 3,774 non-HDR images. The value mentioned by them is different than the actual data sets. This data set is collected from the region of Delhi over different locations in Delhi, which is in India. And even though they have taken from different locations, they have taken a temporal set of images. So these data sets vary from 500 or 600 temporal data sets per location to roughly around 50-60 images per location. They also have HDR data set, which consists of 1,000 images, like 400, 500 varied images. Our research objective would be to understand and use the most optimum layer in CNN network, which is by using efficient ResNet or assembled ResNet and assembled ResNet, sorry. Second, to understand the proper methods of data augmentation for image data set. As we see here, the data set which I have, even though it shows 3,774, the maximum images which are there in one particular small data temporal group of data set is roughly around 500. So image augmentation would be needed to be done. Dataset augmentation would be needed to be done. Third, to understand the difference in the results by using HDR images and normal images. As HDR images gives us more clarity of the more clearer photo. Fourth, to understand the proper parameter tuning, like pre-processing of the images, hyperparameter tuning of image processing, machine learning algorithms, and also tuning of weather data. Visionaire also gives us the complete set of weather data. So hence we can use meteorological features and images. Fifth is to understand the machine learning with impacting meteorological features affecting 2.5 with 2.5 PM 2.5 with the output of CNN network to make a better estimation of PM 2.5 value. That is to develop an efficient ResNet LSTM network and assembled ResNet LSTM network. Operational definitions. PM 2.5.
Sorry, Anupam,
Yes.
sorry.
Yes.
Before we go that part, I just have
Yes.
one question. Why we have to compare HDR image with the normal image? What is the key of this comparison?
So that in future, if we obviously the HDR images would give us, as we can see here, the HDR photo gives us a better understanding of the image. Means like the contrast and the whole definition of the objects and the particles in there are better represented in an HDR photo. Like how I was trying to make an ISO, means like optimized ISO and saturation in my previous presentation. On a similar way, if you can see the clouds out here, they are much more well defined than the clouds here. So so it will help in creating if it makes a lot of difference, then people would start to use HDR images than the regular photos.
So you want to
and there is yes, no, I want to use both the images, but at the same time your question, like why do I want to compare the two results, is because ResNet is robust to noise. So it kind of adapts to the noise features and it doesn't let it affect much. So this is basically, you can say, because of the uneven contrast, would it actually make a difference using an HDR photo or a regular photo? So even that would be understood. Or this is just a hearsay. So comparison between the both would be a better idea. And plus, I have the data sets also for it.
So in the reference that you reference from the paper, they use HDR also, right?
No, they don't use HDR.
So you shouldn't. So what is the contribution of your work?
My contribution would be introducing assembled network, assembled ResNet, and efficient ResNet. They are using a residual network. It's like using a stock car and basic car and trying to improve its accuracy, efficiency, and the complex computational complexity of the algorithm. And I have checked, the previous research had used residual ResNet 18 and efficient net and assembled net they in not in PM 2.5 estimation, but in other image processing techniques have shown better accuracy and better computational complexity. So I
you
would be,
propose
I would be mostly wanting to use and understand assembled ResNet. Means it's like making small modifications to the car to, means like if you have a car and if you make small modifications like change the turbo and decrease the weight. So this is what has been done to the assembled network. So by that, the performance of the network would be better. Here, not much tweaks can be done, as it is like a, let's just say, extra kit given to you. So the channel, the width scaling, depth scaling, resolution scaling, and the whole compound scaling happens. But it just we have to just put it in a formula and then understand how big the residual, means like the efficient net we can make. Also, at the same time, in the previous research, in this research, what they have done is they are using pixels of 224 into 224 resolution. And if you reduce the number of pixels, according to me, in PM 2.5, what will happen is you would actually decrease the concentration of the value, which would result in not giving a proper estimation. It's like it would give a proper estimation, but decrease in accuracy comparatively. So here I want to use double the number of resolution. By using double the number of resolution pixels, okay, sorry. And by using efficient net, I would understand by doing reverse calculation how deep my network would be. At the same time, I would try to make the assembled net also at that particular depth. So I will get a base by using higher resolution, which I wouldn't understand with residual network, which the previous paper had taken. Because I remember when I had given the paper review of this particular paper, that time the question of was asked to me, asking that why 18, why not 50? Why is the depth kept to 18 and why not 50? So when do you understand that this is the optimum layer required for this particular project or for this particular question, for this particular problem? So efficient net will give me that answer. At the same time, I would compare the layers with assembled net and try to make more tweaks. Actually, there is one more thing which I wanted to ask, but I will ask after the presentation is done. There's one more thing which I want to do, but I'm not sure about it.
So did you read from another paper or reference that they use HDR, right? I mean, do you
HDR is used by this particular group, Visionaire.
Actually,
and before that, last week which I had presented, I was talking about ISO and saturation. I wanted to use that to make a data set. And unluckily, I came across this data set which uses HDR, and basically HDR is tuning the ISO and the saturation. So my novelty of the research goes out of the window, but still I can make this because this is already done. HDR is already done. I wanted to tweak and optimize the ISO and saturation for understanding what as ISO is needed and what saturation is needed to take a better data set. Here they are directly using a function on a mobile phone, HDR function, and taking the photo.
So you use your mobile phone to capture the photo, right?
Yes, means I wanted to do that if I was making a new data set.
So I think you have to take a lot of photo to make
Yes,
it a
yes. But so hence I decided to use this and drop that novel point of ISO.
And I think it's good idea that you use HDR because it's during you have to do like a feature extraction from the image. It can
Yes.
make you more features and detail in the image. But
Yes.
the thing is you increase the dimension of the image, right? I think it's good idea. But
yes,
the thing is your contribution is quite not clear as
my contribution would be increasing the image pixels, means for the pre-processing, and use of efficient ResNet and assembled ResNet instead of ResNet.
Okay. So I'm not sure whether it's okay or not. It's just change the dimension of the image, right?
If you change the dimensions, if you increase the dimensions of the image, then more features can be extracted out of it. And by using efficient net and ResNet, they also provide lesser computational complexity compared to the original ResNet, even though the depth increases, especially in the assembled net, as they use sometimes they use 3x3 convolutions instead of 7x7 convolutions. Sometimes they use drop block and selective kernel. So I would get to study about that more and try to make a optimized network.
Okay. Please go with your presentation.
Okay.
Please continue.
Yes. PM 2.5 of the operational definitions. PM 2.5 are fine inenable particles with diameters that are less than 2.5 micrometers or smaller. The PM 2.5 are correlated with the image features and meteorological data and will be estimated using the following image processing and machine learning methods. In image processing is a method to perform some operations on the image or in order to get enhanced image or extract useful information from it. It is a type of signal processing in which input is an image and the output may be a characteristic, a feature associated with that image. The features of image will be extracted using CNN networks, deep CNN networks, which are assembled ResNet and efficient ResNet. Machine learning is a branch of artificial intelligence and computer science which focuses on the use of data and algorithms to imitate the way that humans learn, gradually improving its accuracy. We will be using machine learning for regression learning between the weather data and image processing feature output. Will be done via LSTM machine learning model. The performance matrices. The first performance matrices which we'll be using is mean absolute error. Mean absolute error is a model evaluation metric used with regression models. the mean absolute error of a model with respect to the test is the mean of the absolute values of the individual prediction errors on the overall instances of the data set, test set. Here, YPR refers to the predicted value and YRE is the real value. The second performance matrices we'll be using is symmetric mean absolute percentage error. The symmetric mean absolute percentage error is an accuracy measure based on the percentile or relative errors. Here again, YPR refers to the predicted value and RA refers to the real value. I was advised to use more performance matrices last week. So I came up with mean deviation rate. Mean deviation is, or the average deviation is defined as the mean of the absolute deviations or observations from the suitable average, which may be the arithmetic mean, the median, or the mode. Your fx is the ith sample of the PM 2.5 estimated value, and y is the true PM 2.5 value. By this, we'll understand how the values change with the proper values. Literature review. The first literature review would be, which I've already done, is ResNet LSTM for real-time PM 2.5 and PM time estimation using sequential smartphone images. This research shows how deep learning model integrates residual network with LSTM, extracting spatial temporal features of a sequential image taken from smartphones for estimating PM 2.5 and PM 10 values of a particular location at a particular time. The pixel size here are reduced to 224 into 224, and ResNet 18 model is used to extract the spatial features of the image. Hence, in contrast, proposed research will consider the increase in pixel size to 448 into 448 to get more spatial feature extraction and convolve the features in a systematic way. Use of assembled ResNet and efficient ResNet algorithm instead of ResNet 18 will give us lesser computational complexity and better accuracy than ResNet 18 model, or even if more number of layers would be used. Now this is I'm hoping. Second paper is air quality measurement based on double channel convolution neural network ensembling method. In this paper, the image of the data set is taken and the sky and the ground view, a line is drawn between them and the image is cropped, making it two images, and they are convolved separately using double channels, and then later they are assembled. So because of this paper, because of this paper, we would understand the ensemble learning and how we can use dual channel convolution. Third paper is compounding the performance improvements of assembled techniques in a convolutional neural network. This paper is about assembled ResNet techniques. This paper shows how modification to residual network architecture with several tweaks, such as ResNet D, channel attention, anti-aliasing downsampling, and big little network, create a new network called assembled ResNet with better accuracy and less computational complexity. It also gives comparison study of different scaled ResNet models with efficient net and efficient and assembled net with lesser depth performance. And with lesser depth perform better. Efficient net. Rethinking model scaling for convolutional neural networks would be another paper which I want to review. This paper shows systematic study of model scaling and shows that carefully balancing the network depth, width, and resolution can lead to a better performance. As I mentioned earlier, I want the resolution to be 448 into 448. So this will help me in understanding more how to go about it. They propose a new scaling method that uniformly scales all dimensions of depth, width, resolution using a simply yet highly effective compound coefficient and introduces efficient net. As use of bigger image size 448 into 448, we get more efficient net. We would help to provide optimum number of layers with better accuracy. I am not being able to see the screen here. Okay, the conceptual framework research approach. In this, we see that the research approach is divided into 3 parts: data set, data manipulation, and into 4 parts: data set, data manipulation, feature extraction, and regression learning. In the data set part, the temporal data set is taken. Actually, it is spatio-temporal data set, but we would keep it to temporal data set because I don't want to mix it up. Training and testing images would be taken, divided. At the same time, it's like in the next slide, I will show you what I would want to do. Weather data set would be taken, and tuning of weather data set as per the images would be done and aligning them. Then in image pre-processing, in data manipulation, and we will do image pre-processing, in which we would do data augmentation, means like data set augmentation of the pre-processing images of the images, and we would do weather data tuning on the other side. And then we would send it to feature extraction. In feature extraction, we will be performing image processing method on it from the weather, and then this output and the tuned weather output would be given for machine learning, in which regression learning would be done, and hopefully a better estimated PM 2.5 value would be given. So this is the research design, in which we would take, in the first data set, we would take the data set of HDR and non-HDR separately. Sorry, perform data set augmentation on it to get a bigger scale of data set. Then we would divide it into training data set and testing data set. These training and testing data set would be given for pre-processing.
Sorry, Anupam.
Yes. I made a
just
mistake
have
out
one.
here.
Yeah, I just have one question that.
Yes.
So far, what is your result that you expected
Result
from your model, from your research?
What is the result?
What is
actually
the
develop
expected
a
result?
new model? To develop a new model, in which
result from the model.
This model.
Yeah. What is the result? You said
PM 2.5. Yes, 2.5
2.5 value, right?
Yes.
So you just predict the value from PM 2.5.
Predict also, and this model also means like it would be able to forecast the value also, means for the next, means like depending on the parameter tuning, this would also be able to forecast the value.
So what is different from the website that they already check the PM 2.5 value every day. This is I'm just confused that what is different accuracy, or so they have some website, right, that we can check the PM 2.5 value every day or
Yes, yes, yes,
something
yes.
like
But
that. So what
yes,
is the difference between your work and that website, or that, or we
the
have
vision,
also have
yeah, because there are many,
some
many,
yeah.
there are many applications also where we can check
Yeah.
the PM
So
2.5.
what is different? What is the like
Means
benefit?
this will improve the accuracy of the already existing algorithms.
So you have to compare your
Yes,
accuracy.
yes, 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 yes.
So how you can calibrate the accuracy? You said your accuracy will be higher than the Vision Air website or some application, but how you can calculate, how you can
I
calibrate
have
that?
I have the Visionaire data code also.
No.
Means I got it from GitHub, so I have the whole code of Visionaire. So I will be
You
comparing that code also with my code.
No, I didn't go to the technical detail yet. I just asked how you can observe that your algorithm that have higher accuracy than the website or the application that
By
already.
using the same data set and performing the same process through them, and then understanding the error rate, the accuracy rate, and also the computational complexity of it.
I did not get you, sorry.
By running their model also and my model also, and then comparing it with the same data set, using the same data set, and then trying to get the accuracy differences.
So you said that you will compare the
Yes, yes.
PM 2.5 value with their, sorry,
Yes.
that
Yes.
you have data set that they already have, right? That they use, right?
Yes.
But you said you will increase the size of the image, right?
Yes,
As the
yes,
contributions.
yes.
So then you will compare with the same size of the image.
No, I will just compare with their program. It's like what they have done. And I want to actually compare it with the ResNet 18 also, if I'm able to get my hands on the actual code.
But I think nowadays we have some website or some machine that can inform us about the PM 2.5 value, right? I'm not sure.
Yes, yes, yes.
So what
means
is
like
different?
means like means you don't even need images, I think. What is different is the estimation, the accuracy of the value which is informed by the
At
website.
first, I think you will predict the PM 2.5 value in next 7 days or in a week. But now you not predict, right? You just say like
Estimate
the currently value,
yes,
right?
yes, yes,
It's not
yes.
predict in the 7
No.
days or so. What
No,
is
it would be able to do that, but I'm more focused on the estimation by looking at the image rather than taking the whole data set and trying to predict what the next value is.
I'm just wondering how you can calibrate or claim that you have higher accuracies than
by comparing with their code, with their model,
because
and
now
their accuracy values are already given in the papers.
so you said you will claim with another paper, right? Not
Yes.
not with the website that they already shown.
With that also I can do the website, the Visionaire website. If you're talking about, with that also I can do, because I have their code. I've already downloaded their code.
Okay.
So I can make it run and directly compare. And they have, means like even that would be not needed of running their code because they have given their accuracy values also on the site. So I can just check my this particular algorithm and then see what the accuracy value is and directly compare.
I just wondering on the just confused about why we need it. Just that's all, because in the website we also go to check easily.
Yes,
right?
yes, but the accuracy is not 100%. When the accuracy becomes 100%, then we might think why we need it. But if there is a scope of improving the algorithm, and even if the accuracy is 100%, the computational complexity also matters.
And I think your model that you train also take a lot of time for sure, because bigger image, CNN
Yes,
first,
we
and go to
are
LSTM.
using bigger image, but we are okay. I will give you an example. We are taking a bigger engine in a small car because we are going to have a lot many tweaks inside the whole algorithm to make the computational less. Means like if the ResNet 18 they are using 7x7 convolution, we would be using twice 3x3 convolution. So making such tweaks, we would try to change the difference. And at the end of the day, even while making a resolution less to 144 from the original, they took time, right? So even that should be considered.
So you said that it will not take a lot of time, right, to train your models?
Yes, comparatively, it should not take a lot of time because in their model they change the resolution to 144 by 144. Even that process should be considered, right? Means changing into half of the size or 1/4 of the size would also need some computational time and some computational space cost. Means like if there are two people and two people are getting the same 1028 by 786 images, one is going to change it to 144 by 144 and the other is going to change it to 244 by 244. It's like 224 by 224.
Can you
and
go back
448
to resident network, because you said about resident network, right? Which part that you changed?
Which part? A lot.
Yeah,
I don't have resident networks complete detail on this. Can I just share it
No,
from
no,
the
no.
website?
Just I think you have in the blog, right? Assembled.
Yes, assembled. Yes. So there are many parts. ResNet D and SK. SK is the selective kernel. ResNet D is the what do you say? Means like there are three changes which are done in ResNet D. One is the stride size, means of the first two convolutions that are changed. Second, in 2x2 average pooling layer with stride of 2 is added before the convolution in the skip layer connection path.
Okay. So I will not go to the detail of the technical detail yet, but the concept of your work, that I just wondering that how you can say that you have higher accuracy and the time that you will have to use during the training model. I don't think it will be less. That's my opinion.
Even if it is more, see, if here 2 blocks of 3 into 3, it's like 1 block of 3 into 3 is used, or 2 blocks of 1 into 1 is used, that way our
You
depth
use,
will be increased.
sorry, you have experience about coding CNN before or not?
And not.
Yeah. So if you have time, you should practice it, because
Yes,
resident
yes, yes,
network is the improvement of CNN, right?
yes,
Because the problem is vanishing gradients. That's why we
yes,
have to residential block
yes,
to keep the feature or to keep the detail of the system. So if
yes,
CNN already took a lot of times, and we have to keep the feature from the previous layers or the
yes,
system. So I don't think resident network will use less time. I think it should be have a higher time than CNN in my opinions. And for LSTM maybe if you complete the assembly assembled resident ResNet,
assembly, yes,
yeah, maybe
yes.
you will use less time, maybe just my
Yes, that's
opinion.
there, but I read a few papers in which comparisons of AssembleNet, ResNet, and efficient nets were done for different methods for different things, but which clearly stated, means like the paper which I would be reviewing, even in that paper it is mentioned. Compounding performance improvements of assembled techniques in convolutional neural network.
It will be improved resident network for sure, for
Yes.
sure, for sure. And you use HDR, right? Your feature in the image will be
Yes.
increased, and you use
Yes.
feature extraction,
Yes.
so it will be increased.
Mhm.
So I just have like a general question about the why. What is how you can claim that you have higher accuracy from that model? That's all. That
Yes,
I
because
question.
I made a few comparisons of assemble techniques with ResNet techniques, means like the base ResNet model with assembled model, and also efficient net model. By far, efficient net is of most accurate model of the three, and assemble net is coming nearby. So, and assemble net has less computational complexity. Even efficient net has less computational complexity. The whole comparison. Can I just open the comparison?
I think it's okay. You can continue your presentation, or others people or other
Okay.
Ajahn have some question or not. If no, you can continue.
So, but I had a question for you. Means like, since we are talking about it, I had a question.
Yes.
In residual network or in CNN, the first step which we use is convert the RGB to grayscale, right?
Yes. Yes.
Can I have a 3 parallel feature extraction methods? Means like in this paper,
Actually, it's depend
ensemble
on
learning. Ensemble learning. Can I perform ensemble learning on red, green, and blue parallelly? And then instead of getting one vector output, getting 3 vector output, and using LSTM, instead of using single LSTM, double led LSTM use would be done, in which the first LSTM would take care of the metallurgical factors, and output of the first LSTM would be given to the next LSTM, and output of the image process, the 3 vectors, would be given to the second LSTM, and then regression analysis out there, another regression analysis out there. I was just wondering if that's possible.
Actually, input should be the same. You understand my point?
Input should be the same.
it should not be like you said, like you use some data adding increase on other part, right? It's not
No,
you
what I
use
mentioned,
RGB, right?
RGB, yeah.
And this is
RGB
for
in
input.
vector form. In vector form means like output
yes.
of the CNN would be in one vector in these methods. Means like
Actually, it
512
depends
into
on your
1.
design.
Yes. But
If
would
you
it be
design like that,
would it be better? Means like would feature extraction be better that way?
I don't know which one it will be better. You have to try.
Okay.
Because if me, maybe I use binary image. But
Okay.
let's see what I don't know what it is.
Okay.
Because yeah, I also don't know because you have to try.
Because like I means it's there, RGB is divided by 3 directly, so a lot of features might be dissolved in the start itself. Means like when RGB becomes too gray, they directly take it and divide the whole thing by 3, right?
You try, because some
Okay.
people said that if we have some like a lot of feature, the graph will be overfit. But let's see that what is will be happen.
Okay. Okay. So this is the research design which we spoke of. The research methodology would be data sets containing HDR and non-HDR images and weather information during the same time. The images will be augmented and then divided into training and test data sets. The images will be then pre-processed to the resolution of 448 into 448 for convolution. 2 types of algorithms, efficient ResNet and assembled ResNet will be used for image processing for the feature extraction. The output one-dimensional vector will be taken and given to the LSTM for regression with weather parameters for estimation of PM 2.5 value. The test data will be then tested on the system. The result of the testing dataset would be tried to improve using hyperparameter tuning. The results would be tested for both types of algorithms and both types of datasets. MAE, MDR, SMAPE will be used as performance matrices. The novel points would be pre-processing of pixel density to 448 into 448 instead of 228 into 228. The second would be use of efficient ResNet LSTM and assembled ResNet LSTM instead of ResNet LSTM, ResNet 18 LSTM. In image-based PM 2.5 estimation. The third was if it's possible or not. Means I'm not sure about it. Is doing 3 parallel convolutions of R, G, and B separately, and then giving an output of the CNN network in 3 outputs, 1 vector, 3 outputs, 3 outputs of 1 vector dimension. Scope of the research would be a data set obtained from Vision Air will be used for the study. A regression analysis for image-based features with meteorological data like humidity, wind speed and direction, temperature and pressure. Understanding the effects of training the network with HDR and non-HDR image type datasets. Exploring the permutation and combinations of 2 highly efficient algorithms in ResNet CNN. The first one being the assembled ResNet, finding the optimum balance of the network tweaks and the depth required. Second is the efficient ResNet, trying to extract features by increasing the accuracy by using images with higher pixels. The research will be conducted in OASYS lab, Chiang Mai University, Chiang Mai, Thailand. The computer used I'm not sure about this. I've just given my computer specifications. Processor i5 9th generation, CPU 2.4 gigahertz, RAM 8 GB. I will increase it if it's needed. GPU GTX 1650 with Max-Q design. Dataset taken would be from Vision Air dataset. It is on this website. PM value in this dataset ranges from 10 to 256. Programming language used would be Python, and I think mostly I will be doing it in Keras. Research advantages. At the conclusion of this research, we would understand the following: which algorithm performs better in PM 2.5 estimation? Is it efficient ResNet or assembled ResNet? I will add. Oh, sorry, I've been making this presentation. Sorry. Which algorithm performs better in 2.5 estimation? Efficient ResNet or assembled ResNet? Second, is there any difference in the accuracy due to 448 into 448 pixel size instead of 224 into 224? What is the optimal depth of the neural network needed for PM 2.5 estimation? This is the duration and the time plan. The literature review would be till I would try to read a lot and at the same time give literature review June, July, August, September, October. Arrange and get the data set ready June, July. I would be trying to get more data sets also. Sir, I had one more question. Hello?
Yes.
Sir, in PM 2.5 means like you must be knowing of Vision Air dataset, right? Not Vision Air, Dust View dataset.
Yes.
So the Dust View dataset is taken roughly around 3.5 to 4 kilometers from the values measured. Means the values are taken from station 36T, which is roughly around 3.4 to 4 kilometers. And the images are taken in near Chiang Mai University. And yesterday itself, I was able to get the complete weather, means like understand the resources to get the complete weather parameters also for the time of the photos which we have of dust view. So would it be effective, sir? I mean, I have the complete data set and even the weather parameters of station 36, but the photos are
Yes.
taken in Chiang Mai University, which is 3.4 means like kilometers, 4 kilometers away from the station. I'll just the distance between Chiang Mai University and this thing, the station is more.
Uphalat.
Yes, sir.
Yes.
Hello.
You mean Uphalat station?
Yes.
Station that you talk.
36 station 36T.
So which station พี่อัน
ใช่ครับ สถานี
16
มันอยู่ที่ยุพราช
So and then you ask that if you capture the image at Chiang Mai University, right?
Yes, and the data is taken of station 36.
So
and in this website, Chiang Mai University means like these particular coordinates are the same as station 36. And if you see out here, sorry, these are the latitude longitudes of station 36, and the complete data means like this is a random time which I chose from 1st June 2019. I can get it till previous also. I can get till 2013 also. And all the parameters are also there. But the only point is PM 2.5, the photos taken are 4 kilometers away from the station. So would that matter?
So I think you have to ask some expert that is whether it's okay or not. I'm also not sure that if they have the distance factor, it will be affect your model or it will be affect your value that you got or not. So maybe you have to ask some expert one.
Or means like art has portable sensor, right?
Yes, that the question that I ask you, what is different that compare with the portable sensor? You understand my point? You said you will
Yes.
show
Portable sensors. The difference with the portable sensor is that the portable sensor uses light scattering of the PM 2.5 particles.
But we also can get the value from PM 2.5, right?
From the phone?
Portable.
From the portable, yes. But the portable sensor means like as mentioned earlier, not everybody is able to afford it. And not everybody carries it with them. But
So
you carry a phone with you.
So you have to highlight your work.
Yes, I had mentioned this.
And your flow of slide is quite jump. You understand my point? You said it's not. It should not be in the you said resident and you go to input data. It should be input data first, or the contribution literature review first. Maybe you ask some
first
senior
input
student.
data. Yes, I will do that.
In the lab.
First input data, then process. Okay.
For me, that's all.
Okay.
อาจารย์นันท์ครับ
ครับ
คีย์เมื่อกี้ก็คือเขาพยายามรีเช็คว่าเขาจะสามารถใช้ตัว Data ที่อยู่ที่ยุพราชกับรูปของเราที่ตึกได้ใช่ไหมอันนี้เมื่อวานเขาก็ถามว่าประเด็นก็คือตรงยุพราชมันก็มองเห็นดอยสุเทพเหมือนกันมันผลสุดท้ายเดี๋ยวมันจะไปสื่องานเขาได้ซ้ำไปว่าเดี๋ยวเขาจะเอามือถือขึ้นมาถ่ายแล้วมันจะต้องได้รูปกลับมาแล้วมีค่าด้วยอย่างเงี้ยก็เลยมองว่ามันน่าจะใช้ได้เหมือนกันนะตอนนั้นก็เลยตอบไปอย่างนี้แต่ว่าให้รีเช็คกับ
อันนี้ไม่รู้เลยเพราะว่าพอไม่แน่ต้องถามอาจารย์ที่ปรึกษาอาจารย์ภาสเนาะต้องถามอาจารย์ภาสว่า
น่าจะ
หรือเปล่า
ครับ
ถ้าแกโอเคก็ไม่น่ามีปัญหาไม่รู้ว่ามันได้หรือเปล่าแต่จริงมันก็เห็นดอยสุเทพนะครับมันก็น่าจะได้
มันคือมันต้องได้แหละไม่งั้นมันจะอยู่ที่ไหนถ่ายมือถือด้วยมือถือแล้วได้ค่า PM ได้ยังไงในเมื่อมัน point of view มันต้องมองไปสักที่นึงหรือว่ามันไม่ได้ถ่ายฝุ่นในอากาศนะตอนณบริเวณใกล้ๆซะหน่อยใช่ไหมในคีย์ของงาน
นี่ไม่มีความรู้เลยว่า
ไม่รู้ว่าระยะมันเกี่ยวหรือเปล่านะเพราะว่าถ้าจากอย่างว่าจากเครื่องเรากับเครื่องนี่มันห่างอยู่นะถ้าฝุ่นเยอะๆมันก็อยู่ใกล้งั้นมันก็เห็นนะแต่ว่าถ้าอยู่ยุพราชอาจจะไม่เห็นเลยก็ได้นะ
ก็เลยบอกว่าเป็น reference หนึ่งแล้วก็บอกว่าน่าจะเมนหลักน่าจะเป็นเลยนะ virtual air ตัวนั้นน่าจะโอเคกว่ากับ data set
อยู่ที่ระยะกับวัตถุที่เราจะ observe ข้างหลังด้วย
ก็เลยว่าให้มารีเช็คกับอาจารย์อีกทีวันนี้ครับ
ถามอาจารย์ภาสเลยว่าแกโอเคหรือเปล่าแต่น่าจะได้เนาะไม่รู้เหมือน
ลึกนะในเชิงคอนเซปต์คือน่าจะได้เพราะว่ามันเป็นวิวเหมือนกันมันเป็นวิวเฉยๆมันไม่ได้วัดค่าโดยเซนเซอร์ direction ตรงนั้นเทียบกันเป๊ะๆอะไรอย่างเงี้ยแต่ไม่รู้ว่าจะยังไงเดี๋ยวลองดูอีกทีนะครับครับ
มีใครจันแบงค์หรือใครมีอะไรเพิ่มเติมไหมครับ
ไม่มีครับ
งั้นจันแบงค์น่าจะวันนี้น่าจะแค่นี้หรือเปล่าหรือว่ามีอะไรอีกไหมครับไม่น่ามีแล้วเนอะ
ก็ไม่มีแล้วครับ งั้นเดี๋ยวกด
สวัสดีนะครับทุกคน